Going to the cloud, I hope, right? Good afternoon, and welcome to the Music and Technology Seminar at Carnegie Mellon. Our guest today is Francesca Ronchini, who is well-schooled in both music and technology with a master's degree in computer science from Politecnico di Torino and a master's degree in sound and music computing from Music Technology Group in Barcelona, Spain. She is currently pursuing a PhD at Politecnico di Milano Image and Processing Lab. Francesca, devo dire che siamo tutti onorati da fare la sua conoscenza.
I was looking for the call for Yes, she is. Or a nurse has to, but his nurse is currently at lunch. So I have to get a hold of a different nurse because I'm not a nurse. Okay. Yeah. So I don't want to touch it because I don't know.
Can somebody mute their phone, please?
Yeah, I think it was mine. I think
I know how to do that. I'm not, that's not my job.
I got to mute this.
But yeah, there should be
Sorry.
a nurse around.
All right, yeah. Francesca, you're muted if you're talking.
Okay. Now you can hear me, right?
All good.
So hi, everybody. I'm Francesca Ronchini, and thanks for the presentation. Thank you so much, Ricardo. And I'm really happy to be here and to present like a bit of my research. So today I'm going to talk about opportunities and challenges of text to audio generative models, but also focusing a bit on text to music. But before that, I'm just going to introduce a bit about myself. So I am a PhD student currently from Politecnico di Milano in information technology. But I'm from a village, like actually a city close to Rome. So I'm actually from Viterbo, which I really invite everybody to visit if you happen to be in Italy. And before that, before like being introduced, I have 2 master's degrees, one on sound and music computing from Universitat Pompeu Fabra in Barcelona, and a Master of Science in Computer Science Engineering from Politecnico di Torino. And before that, I've been involved in research in the last couple of years, focusing on sound feed reconstruction, sound event detection, and sound event localization. But I'm currently, my main research focus is about advancing audio generative models so that can be safely integrated in the society. And currently I'm living in Pittsburgh, so I'll be here for other 3 weeks. And I'm working as an intern student at Bosch Research, where we are researching and trying to understand about the limits of generative AI applied to audio application. Just a couple of words about the lab where I'm pursuing the PhD. I'm pursuing the PhD in the Image and Sound Processing Lab in Politecnico di Milano. We are a lab of about 10 faculties, 4 postdoc and 14 PhD students, and recently we have been joined by 2 research assistants. The main research lines of our lab are focusing on audio processing and image and video processing, but we also have like a line of research on geophysical data processing. We are split into different campus, one in Milan and one in Cremona, which is a city of about like 1 hour driving from Milan. And there we have the main facility in terms of we have a musical acoustic lab and we have sound and music computing lab. We also have a Master of Science in Music and Acoustic Engineering. This is pretty new. And there are 2 tracks available, one mainly focusing on acoustic engineering, and it's mainly run in Cremona. And the second one is about music engineering, so giving more focus to music and computing. And this is mainly run in Milano. And the master is called Master of Science in Music and Acoustic Engineering, and it's like about 2 years. I just leave a couple of information if you want to have more information about. The first link is about the master, and the second link is about the lab, the Image and Sound Processing Lab. So today I'm going to talk about generative model and focusing on text to audio. So I think like most of us are familiar with this interface and the content and the generative models. This is ChatGPT, is a text generative model. And just to give an introduction and take it as an excuse to like give an introduction about the talk, I just asked ChatGPT to say hi to the music and technology seminar folks nicely. And this is like the answer that I got from ChatGPT. But I also have another example of generative models for images. And those are two images that are the output of a Stable Diffusion model. And the prompt that I use to receive this picture to output those images from the model, it's give me a picture of music information retrieval folks attending a music information retrieval workshop. And as you can see from the images, you can play with styles. So I ask for a realistic image and I also like a futuristic image. And those are the results that I got. But those are just couple of examples of like generative models. But nowadays we have like generative models for all different type of content. But what are content generative models? They are deep learning architecture that have been designed to generate content. And as we just saw, I just give like a couple of examples. We can have generative models really like generating any type of media that we might think like right now. We have generative model for text. We have generative model for images like Stable Diffusion, Midjourney. We have generative models for music and audio. And we also have generative models for video. They became really mainstream in the last couple of years. But in my opinion and my idea is that it's now time to step back and to think how this model can be actually applied to creativity in terms of opportunities and challenges. And I won't getting deep into like history of music and technology, but just to give like a brief history about it, it's not with generative models that we start to see creativity like with computers or technology tools, but the creation of music using any kind of automation has been pursued for centuries. So we have sample of like dices selecting pre-composed expert in the 16th centuries, but we also in the 1957 we had the first score composed by a computer. And over most of the 20th centuries was dominated by algorithm composition techniques. We can think about like Markov-chain, genetic algorithms, grammars. So it's not about just generating music, but it has been like, we see technology be involved in music for a few centuries now. With the deep learning, when deep learning arrived, it has been kind of a revolution. So deep learning, that are machine learning techniques based on neural network, have been also involved like in music creation. And there have been tech companies that start creating research group devoted only to music generation. We can think about Spotify, Google, Meta, Sony, and Magenta, the project from Google, or Ancient. And in the last couple of years, we have seen the introduction of text-to-music models or text-to-audio models that have been like a really new revolution about how to generate music and how to make music. And today I want to focus on them. So text-to-music model are deep learning architecture that have been designed to generate audio clips and music based on textual description that we refer to as prompt that are given as input to the system. And here I have an example. And I have like the two slides that I will introduce now are based on like giving example of text-to-music models. And for the one that might not know about Suno or Udio, Suno and Udio are two text-to-music models. They are commercial text-to-music models that have been available this year from January, actually like Suno December 2023. And I generated two piece of like, just to give example, two piece of like audio sample giving this prompt, which is a fusion of reggaeton and electronic dance music, which includes the experience of being lost in space and evoke a sense of wonder while being danceable. This is the input prompt that I gave to the system. So the text-to-music model works taking an input that is a text input, and then it generates an output, which is a audio clip. And this is the audio that I got. And you get the audio also like with a title. This is also a title given by Suno. And this is the other example, just giving the same prompt that I've taken from MusicML demo page, which is a text-to-music model, and using audio. So really a total like different output. But text-to-music model, there have been like a really exponential timeline and exponential number of models that have been proposed starting from December 2022, where diffusion was proposed, was I guess like the first text-to-music model. And nowadays we have many text-to-music models coming from academia, coming from the industry, but also commercial tools such as Suno and Udio. And I don't want to get into technical details, but text-to-music model can be divided into different model families according to the technology that they are kind of like made of. We have autoregressive model, non-autoregressive model, diffusion-based model, and lately also autoregressive diffusion transformer, mainly for speech, but I guess we will see some of them for music and audio as well. But today I want to focus on the opportunities and challenges of this model, and I will start from the opportunity side. And as an opportunity, I see that they can be really a revolution for music production and composition. Text-to-music models can also bring new way of human AI collaboration and creativity, and we start to see some of them, for example, like Dan Deacon that has been recently in Pittsburgh. We have done like collaborated with Google Magenta using MusicLM for a show. And it's nice somehow to have the possibility to specify synth and samples parameter just using text, but there are still a lot of open challenges and open questions that need to be answered and that need to be tackled, such as how to control this model, how can we use this model without having the computational resources sometime. So there are still a lot of open challenges, but I see it as an opportunity for the next generation of music production and composition tool. It can also be seen as an opportunity for music education because text-to-music models could provide a really intuitive method for creating music, especially if you are at the first stage of you're just learning about music. You can have a fast draft of some musical idea. Sometimes that can happen if you want to try like something new, some new sound, and maybe you are not able to generate with the tools that you have. And I also think that it's really nice opportunity to broaden the audience to music and to allow and democratize the music education and the music creation to a broader audience of people that might be interested in learning music or getting closer to music education, at least at the first stage. And another opportunities that I see is about research and innovation, because those tools can really be considered a really nice tool that can be used to further advance other AI music techniques, but also like audio in general. So for example, we have some applications such as deep learning application of tasks that can be for which it can be really hard to generate data sets, or it can be really hard to gather them for several reasons. For example, for some application, it can be really difficult to gather real world data set because of privacy concern, or because they're not available in the real world, or because it's not easy to actually gather them. And thanks to this model, we have an opportunity to generate data that then we can use to, for example, train deep learning models or any other artificial intelligence model, or to be used together with real data so that can we advance the performance that we have like for some task. And just to give an example, a good example can be a music genre classifier, which goal is to classify the genre of music. So for example, to classify if a music is the genre of a piece of music, is it pop, it's folk, it can be jazz or rock. We can actually generate music using this text-to-music model and use this data to then train deep learning classifier. And also there have been proposed personalization of diffusion model, especially coming from the computer vision domain, that we can use to make simple to generate data sets that can be sometime out of like few data, because we have available only few data. But of course, as any other technology, there are opportunities, but there there are also a lot of challenges that need to be addressed. And the first one is about copyright and legal issue. And there are a lot of questions that need to be solved yet. So which data are used to train these deep text to music models, how to enable the attribution of generated music, how to avoid music deepfake. And recently we have seen, or there have been like, I don't know if you know about it, but there have been record companies such as Universal Music and Sony that sued Suno and Audio because they kind of like were able to prove that this model had been trained with copyright music, and eventually Audio and Suno admit that they use copyright data to train their model. So I think this is a really important topic, and there are a lot of things to do in order to assure like the copyright and the legal issue that that is like a current challenge in using these generative models. Another challenge is about implicit biases, and it's something that we already have seen with deep learning models in general, because deep learning models learn by examples, so they reflect biases and issues of geopolitical and economic characteristics of the world. And text-to-music models are not an exception, and mainly because they've been mainly trained with Western music and most of the resources to train this model are available only to developed economies and to really big companies. And just to give an example of implicit biases, I have been playing with Stable Diffusion and asked to generate an image of 5 pop musicians. And the image, apart of being just 4, is just, as you can see, white people and all guys. And also about like music, I asked Suno to generate a pop and danceable song that talks about summer with a female singer. This is one output, and this is the second one. In my tangled hair, summer groove keeps us alive. So I don't know if we can, I don't know if it's like a female singer, but it took a while before giving like a song with a female singer. So those are examples of implicit biases that we need to be considered, and we need to take care, and we need to consider that when we train or use this data. And the last challenge is about environmental impact. And this is also something that concerns all deep learning models in general. But in the last couple of years, we have seen that the amount of data used to train generative models is really, really huge. And they require a huge amount of computational power to be trained. And of course, this means energy, which means carbon footprint. And this is also like some open challenge, some open question, because we still don't know how to measure environmental impact of text-to-music models and sometimes deep learning in general. And we still don't know what would be the best solution and how to actually have efficient metrics to be sure that the environmental impact, like it's going to be reduced, and we are working like on sustainable text-to-music models. So there are a lot of questions need to be answered yet, but I really hope to see some advancement for this aspect, like in the near future. And this was just to give an introduction about text-to-music models, and because I'm focusing on that. So at the beginning, like I wanted to consider different challenges and different opportunities, and then I also want to tackle both of them. So I'm going to talk about like a study that we conduct. That's a research that we conduct that is called Paguri, which is a prompt audio generator user research investigation. And the motivation behind this study is that the introduction of text-to-music models has lowered the technical competencies needed to use music generative models. But we were curious to see to what extent that can be actually introduced into the music creative practice of nowadays, like music practice. And we also were interested to see in which phase of the music creation practice and if they can actually be introduced for everybody, or just to see like how people will consider this model into their daily music practice. And we developed an application, which I'm sorry, like the image is a bit blur, but we develop a really easy graphical user interface, and then we conduct the study in person. So we open the call for participants, and participants can decide to take the study both online or in person. But even if you decided to take the study online, they needed to be live. So the study lasts 1 hour, and it was like an interactive study. And we developed this user interface, so the participants have full control of the interface, and through the interface, you can input your prompt, and the interface will generate audio for you using audio LDM2 model, which is one text to audio model that had been proposed from University of Surrey. And we also implemented a personalization techniques, and the participant could decide to upload up to 5 audio clips that he or she will bring by themselves, and use those audio clips that they were bringing to the study to personalize the model, and with the idea to give them the possibility to reach the desired audio that I wanted to generate. So it's you can think about it as a fine-tuning techniques to personalize your model. And the students or participants were able to decide if they want to personalize the same model, so audio LDM for scratch and for any iteration, of if they want to keep fine-tuning the same model over and over with the different audio clips. So here is just another sample of the graphical user interface generating audio. And here are the models available. As I just said, like you can decide to personalize your audio LDM2 model from scratch, or you can keep fine-tuning the same model over and over. And we also give the possibility to decide between 3 fine-tuning time. The slow will take up to 15 minutes to fine-tuning, because it will take like more iteration, but you will have a better quality, hopefully. And the fast one is just taking up to 3 minutes, but you have a fast like personalization model, but at the same time, you're losing in terms of quality. And then it was an interactive study. So at the beginning of the study, we were asking some preliminary questions to have preliminary analysis, mainly focus on demographic data, or just to know how the participants were about generative technology. And then for each iteration, the participants was taking like a survey questionnaire, answering question about how satisfied they were about the quality of the audio generated, or about the coherence between the prompt and the audio that was generated by the model. And the participants were able to decide at any different iteration to personalize the model, not personalizing the model, or keep personalizing the same model over and over. So it was up to them. And at the end of the study, we took like a final analysis on the overall experience, and where if they will consider introducing those model or any like the personalization of the model into their music practice, or what if they will prefer like the personalized model or the generative model with no personalization, and any consideration that I had on the generation of audio and music. We got a pool of 24 participants with an average age of 27 years old. 95% were Italian, and even if we try to like spread the call around, and we couldn't get any, not more than a few participants from abroad. I guess one of the limitations was about like the duration of the study. Then we have 75% that were able to mention some AI tools such as ChatGPT or generative tool. 74% were engaged in regular and daily practice of an instrument for more than 3 years, but only 4.2% use text-to-music models to daily or in at least once in their music practice. And I didn't want to give a lot of details on the results that we got, but just I wanted to give some keynote and some not keynote, like key points on the results. And we but the results are, and the study is available online, so if any of you is interested, you can go and check it out, or you can ask me after the talk. Some results that we thought it was interesting is that even if the quality of the audio that was generated, it was not really high or was not considered high quality by participants, it was not everything that mattered for them, because they would consider integrating the samples in their creative process, even just to have a kind of like, they are stuck and they want to have some samples, some new samples, and then take this sample and edit and modify the samples in their like music production practice or for anything that they might be interested in. We also have different contexts, participants coming from different contexts and different backgrounds. Like, for example, we have some dance teachers, we have some person that were not really involved in like any music intense projects or something, but they will consider it as a nice tool to be integrated in their work. And but they give like different results according to the context and the background. So I think it's important to consider to have like kind of like subjective metrics, and I think that context and subjective perception should be integrated when we evaluate text to music models. That's up to now I've been mainly evaluated using quantitative metrics. Most of the participants agree that those models can contribute to democratizing the music creation process, but most of them are aware of the concern regarding copyright protection, and they were mainly concerned about like the possibility of personalizing the model, and kind of like they were scared that if you were able to personalize the model with your sound and creating, so be able to create like a sound signature, then how can you be sure that that sound signature will be attributed to you and people are not using that sound signature for their creation. And then of course a lot of participants say that those models should be more controllable and they would have liked to be able to edit the outcome of this model. So those are between the main features that have been asked from participants. So as a conclusion, we got to the conclusion that text-to-music models will probably be the next revolution used in production, but tech community has focused on making more powerful models, but maybe it's the time to focus on how to use them for creative purposes, how do we actually use them in a way that is fair to the musician, and how do we manage a possible scaling up in the use of such model, because sometimes we really need a lot of computational sources that are not available for a lot of people. And this work is also an outcome of a chapter book, and we are like, I'm personally, but I think that we all agree that how impressive it is, the advance of text to music, but in general generative model. And when the chapter book will be out and it will be published, all of this talk will be already like outdated if it's not already. And also, I wanted to share a couple of results on a study that has just been accepted for the detection and classification of acoustic scene and events. That will be, it's a workshop that will be held in Japan next month. And it's still about like, it's more focused on text to audio, but it's about like one of the opportunities that I just talked during the talk, which is how to use this model to generate data that then we can use to advanced deep learning technology for some task. And the task that I focus in this research is about environmental sound classification. And I'm sorry for like a lot of words in this slide, but the main motivation is because deep learning models require a lot of data and we need to label this data. Labeling data is time consuming and bias prone. Sometimes we don't have this data available. And but we have seen in the past that data augmentation and augmenting the original data set with synthetic data during the training improves generalization and system performances. So I thought that text audio model could be beneficial in overcoming limitation that we had up to now for creating synthetic data, because up to the techniques that we are using right now is either using some signal processing techniques that can be time stretching, pitch shifting, and so far, or we need audio mixing tool to generate the soundscape and to create like new soundscapes. They give control about for example, where you want to add different sources on the soundscape. But text-to-audio models can be really beneficial in overcoming this limitation because you can generate hopefully like infinite amount of data just prompting the model. So what I did, I consider as data set urban sound, which is a data set which contain up to a little more than 8,000 files divided into 10 categories, environmental sounds categories. So you can find like dog barking, siren, or street music, for example. And then I replicated the data set using 2 generative models, which are Audio LDM2 and AudioGen. And the first 2 research questions that I try to answer is that, can we really rely on these text-to-audio generated data to train environmental sound classification systems? And can we use those synthetic data set to as a data augmentation techniques to increase the accuracy of the environmental sound classification models? And the answer is that for the first question, if we can use it and if they can improve the performance of environmental sound classification model when they are used as data augmentation techniques, it's yes. Like I compare with 2 signal processing techniques, which are pitch shifting and time stretching, and all the different for example, here you can see the performance where I use the dataset generated by AudioGen, and here the performance when the dataset is being generated using Audio LDM2, and basically like all of them were able to outperform signal processing based data augmentation. And here, just for the one that I wonder, when there is like AudioGen and AudioGen GPTs, that with AudioGen, I use a really basic prompt, kind of like a template, the sound of like sound class, and where there is like the GPT is that I ask to ChatGPT to generate the prompt for me. And the second question is, can we rely on only text-to-audio generated data to train environmental sound classification system? The answer is not yet, or at least like I was not able to. So also in this case, like we can see that AudioGen is the one working better compared with Audio LDM, or at least like the hypothesis that is able to generate data that are closer to the urban sound dataset, so closer to realistic data, but we are not yet to state-of-the-art performance with urban sound when considering urban sound as a data set. And just out of curiosity, for this study, I use really simple classifier, CNN and CRNN, even if the state-of-the-art performance of classification for urban sound are higher, just because I was not interested in proposing a new model. I was just interested in understanding how to use this text-to-audio model to generate data to replace real data. And then based on the first results that I saw, I saw that we can use them as a data augmentation techniques. They improve performances, but we're not yet in the point where we can use it to replace real data. So I ask like a third research question, that is, to what extent we can safely replace real data using synthetic data and still reach the same state-of-the-art performances. So I replace the synthetic data folder by folder in the urban sound dataset, because we have 10 folders. So I kind of like run different experiment where every time I was replacing more and more data. And as we can see from the results, if we replace up to 20%, we don't lose a lot of performances, but we need less real data to actually train this model. And from replacing like 40–50% of the data, it seems that performances start to drop like quite a lot until we get to the point that we basically are in the situation of just using synthetic data to train the model, where performances drop a lot. And those are also in line with some study that has been published at the same time. And is also like in line with what we are seeing from the computer vision domain. So I think there is a lot to do like in this direction. I think this is a really nice new direction of investigation, and I'm currently also focusing on understand more what's the limitation of those text to audio models, and to understand how to exploit them from like a research and innovation point of view. And I think that this is all for my talk today. So if you have any questions or want to discuss it further, I'd be really happy about it. So let's get in touch. This is my email, and yeah, I try to give a bit of like introduction on what I'm working on and sharing some results about some research that I'm conducting. And thank you so much for your attention.
Grazie, Francesca. E vieni qui adesso.
Should we go there?
Do you want to take a couple questions right away, just in case someone
Yeah.
can't wait?
Okay.
Answer questions before you pedal.
Okay. But
He just asked you to come.
yeah. Okay. Yeah. I don't know how to.
Okay, so we'll just say, that you'll come back, you'll come there in a couple minutes.
Okay. Okay. Then we are going. I'm coming there. Like I'll be there in a couple of minutes.
Very good. It's just
Thank you
gonna-
so much.
You want to go to the door and invite her in when she gets there? Yeah, just hold the door open. You'll see her come down on the hall. So I have a lot of questions. We can keep this going.
Yeah.
Because if we continue in here. So I hope you have some questions to ask Francesca. She certainly has a handle on the information, doesn't she? And, oh, look, we have a nice crowd here. So folks, we're going to continue in a few minutes with Francesca coming here to the studio. Nick's still here?
I don't see him. No, I don't see him.
Does anyone need a project? And aren't you wanting to do that experiment that you talked about? And we could unbalance or rebalance the all Italian people who have already taken that little thing. We should do that, right?
When I saw Cremona, I was like, of course they have acoustic engineering there.
Were you there?
Yeah.
How was it?
It was beautiful. They had the
You
best
still
hot
came back
chocolate.
here.
Yeah.
I'm surprised. I didn't know the Italians had all of this stuff in Milan and these other places.
Mm.
That's why Francesca sit over here, so that she's close to the microphone.
Yeah.
I also need to get everybody to sign the attendance. Did you Francis, Let's see if this.
Yeah.
Can you take a screenshot of this? Anyone have any questions or comments while we're waiting for Francesca to come over? You can't hear me, right?
Hey, while we're waiting, I'll just throw in that one of our recent graduates, Ruben, has been talking to me recently that he's been trying to reproduce Suno in a smaller model and make it open. And there are some copyright issues, but he sent me some sounds, and it's really quite amazing. They're, I think, not as good as Suno because it's a much smaller system he trained himself. But I thought it was quite surprising that he could get as much out, without huge. Well, I don't know how much GPU time he used, but I assume that he doesn't have the resources that companies like Suno and Udio have. He's gonna. We're talking about how to open source the model, and it might be that the code will go out there, and some very small models that are small enough that they don't really produce high enough quality that he thinks he'll get sued by content producers, but we'll see what happens.
I want to point out that in a few weeks, we will have one of the top lawyers in the music copyright area as our guest on the seminar.
Oh, who is that?
His name is Mitch Glaser, and he's the CEO of RIAA.
Oh.
And he's a lobbyist for, I don't know whose side he's on.
I could guess.
But this is a very important position, and he has gained some notoriety in this area. So it'll be interesting to see what he has to say about all of this. I find it amusing that it seems like people are using copyrighted material to create their own stuff.
Okay.
Thank you.
Okay, so do you have any questions for Francesca?
I have lots.
Well, I was just saying that I found it a little amusing that people who use copyrighted material to make their own version of something now want it to be copyrighted.
Yeah. Yeah, I don't know. I think that's a really kind of like I'm not how can I say, like I'm not a professional like on that. Like I'm not a lawyer, I don't know how that really works. But I don't know, I just think like there should be at least some magical, some tool to detect when some data has been used or has been like trained on copyright data or something. Yeah, that's my opinion. Like there should be some magic or something, or at least like some, I don't know, some attribution, some recognizing that this work is possible because of the work of other people. I don't know. Yeah.
Yeah, does this mean the whole copyright system will disappear?
I don't know.
That everyone will get sued, and what if we pass laws in this country and in Italy? You have a different law?
Yeah, exactly.
So,
exactly. That's really, really great. Like that's kind of crazy, like because we are also going into different laws. Like in Europe now we have this AI Act that there is some regulation, but here it's not the same. So we also have different version of some tool that you guys have here in the States. for example, like we have banned ChatGPT for I think a couple of months last year or something. So yeah, we'll see. I don't know.
So I remember the days when synthesizers first started to be used. And at the beginning, they often were imitating real instruments, oboes and violins and so on. And people were up in arms because they thought this would be the end of all orchestras in the world. Because if you have something, a synthesizer or something that sounded like a violin, who needs the violin? This, of course, turned out not to be the case. If you've ever heard a great orchestra, which I'm sure you have, you know that no instrument is going to be replaced by a synthesized sound. But then people just use synthesized sounds to do a whole different type of music, which is also valid as a music expression. And in fact, we have now at Carnegie Mellon a major in electronic music. So people are working with electronic instruments. But I wonder, does the AI now, is the future of people who learn how to read and write and play music in danger?
I don't know. In my opinion, like I also have this idea that it's been the same with digital music, I guess, and with like synthesizer, that everybody was scared, but now like it's good music and it's valid music, as you say. It's like acoustic music, and I think when you go to a concert, there is always like an electronic tools or instrument, and they're being used to enhance the performance. At least nowadays they used to enhance the performance. And I'm also really into like electronic music, so for me it's like it's really, really nice to have all these tools but feel like it's valid music. I don't see that. I see an opportunity for this text to music model, but I like to see them as a way to enhance and go to the next level. But it doesn't mean that that people are not interested in learning classic music or something. And even a lot of like producer or a lot of DJs nowadays that make like really nice and good music, or for the one that likes like electronic music, they don't necessarily need to know like how, or they're not necessarily able to read like now it's the word in English, like the music sheet, yeah. And but they still valid like electronic composer or something. So that's my point of view. Like I'm not the person that think that this model will replace music or something. I just like would like to see how this model can really be integrated in the creative process of people, because in the academia list, or at least from my point of view, all those papers have quantity metrics and some perspective tests, but then like are people really using it? And they are like these big companies sending those tools like, yeah, we're sending these tools for creative purposes. And they're really using the creative pipeline of people, and how or which phase of the music production are you using just to give some sample, some idea, and then you edit and then you start from there, or you're making a music out of it. I don't know. For me, like, yeah, for me, there are different stages. I don't know, like of approaching this text using this generative model.
So is there any danger of our music notation system changing or being eliminated? The one that we've worked for many centuries to develop?
No, I don't think, like, I personally don't think so, but there's also been other like tasks in the music tech like word, like other tasks that I may think of is like to write the shit for you for like from computer, like computer doing it for you. So I don't know. I don't think they destroy like how people are like making.
Not yet, anyway.
Not yet, at least. Yeah.
My job isn't quite in danger yet.
Yeah. But I'm also like, I don't know. I don't like to see these tools as destructive tool or something that will replace the work of people, or at least like the creative work of people. Some work maybe, yes. I don't know. Some jobs, like some type of jobs, maybe. I don't know.
I mean, sorry to disturb, but what I think is that maybe some things like jingles, like
Yeah.
and like music in the background of ads
Yeah,
and something. I feel like those may be more taken over by AI generated
Yeah.
things because it's easier.
Yeah.
But things still like music that we enjoy on a daily basis would still be like human made to some extent.
Yeah, I also
Yeah.
believe so. And I don't know, like this model, it's true they can, at least my experience that is true, they can create like really nice piece of music. Sometimes they can, like, at least like if you maybe are not music into something, you can not recognize that it's coming from a machine. But I mean, they've been trained on data. I think they will convert to the same output sometimes. Like, and they have limits. Like after a while, they will generate always the same things. Like if you play a lot with these models, they have limits. So I don't know how, and I don't know how from a creative point of view, it's how far you can go. I think I agree with you. They can replace some tasks.
Some like simple types of
tasks. At least now, like then maybe in 10 years, like.
Are there any questions?
I'm curious, like for all of the participants in your experiment, what are the top features that they want to edit, especially for the sample?
Most of them want to be able to edit, like they want to control, like for example, like there was this participant, they want to have like drum bass, and then you want to add like instrument on top of it, but he was not able to do it, and then he was keeping like fine-tuning the model with samples, but every time that he fine-tuned the model, then the model kind of like forgets what he learned before. So the guy was trying to fine-tuning the model over and over, but not getting the results that he wants. So in the end, like I say, I will just take the output and edit by myself. Yeah, it was about like controlling parameters.
Yeah, it's like currently with those deep models, it's some sort of chaotic manners that when we have to like slightly change in your inputs, the output will be completely different. But normally when we like cooperate with other musicians, we don't actually want them to just rewrite the song again and again. We just want them to modify based on some of our opinions. Actually, yeah, other generative tools such as ChatGPT can actually do it. When we add some prompt to it, it just don't modify the whole stuff, but they modify some part of it. It's like, can we actually do this in music generation?
Yeah, I think like that's also one of the features that participants were interested in, just modifying like part of the output. There's been a study that does exactly kind of that, like they don't replace it's kind of like timbre transfer applied to one instrument of the output. So you output, for example, like a piece of music with guitar, and then you want to replace the guitar with I don't know, you have acoustic guitar and you want to replace with electric guitar or with a synth. There has been like a publication recently that they're able to do that from Queen Mary University and Sony.
So if the goal is to create music totally by a computer with maybe just a single prompt, do you believe that the future of that is in deep learning or is in some other sort of artificial intelligence?
Yeah, I personally like, I'm still kind of like, I'm also like questioning the same, because we start to see also a lot of like physics informed or like signal processing informed network, or I think like it's not really just coming from, we will see that it will need to come from some other domain as well, as we are starting to see in other domain. For example, like in room field reconstruction, now they're working with physics informed network, just because you need to add some domain knowledge into the network to really perform better than just pattern recognition or something. Because I think they can kind of like learn patterns that you will see in different tasks, but then kind of like generalizing, I don't know how easy it is. I think like, I don't know, I still don't have the answer, but I think we will go to the direction of like integrating domain knowledge into the network, learning network. Yeah.
So you are Italian, and I wonder, have you thought about AI in relation to Italian opera composers? I'm looking for the third act of Puccini's Turandot, which he died before he finished it. And none of us have really been totally pleased with the Alfano version that, you know, completed the end of the opera. Can AI improve and give us the thrilling end that Puccini promised for that opera?
I don't know. I think some maybe people can try. Like, I don't know. I don't know.
Chris,
Give
you
me-
have a
Oh, hey,
Hi.
yeah. Thanks for the talk. Really enjoying this very broad conversation about music and AI and copyright and the future of music and all that. I have a much more narrow question about some of your text to audio work, which I thought was super interesting. I guess so kind of the setting, at least in my interpretation, is one where like, okay, I'm someone who really cares about a particular audio classification problem. Like I want to train a model that can detect if someone is saying the word yes or the word no or something like that. And I have this big data set of like text audio pairs, you know, dogs barking and the label and the text corresponding text dog or something like that. And the question is like, how can I take this big data set, this big text audio data set, and use it to improve my ability to detect if someone is saying yes or no? It seems like there's kind of at least a couple of different ways to approach that. Number one is like what you were looking at, like using that text audio data set to train a big generative model to go from text to audio, and then use that to generate a bunch of examples of people saying the word yes or no or something like that. You could also, perhaps a slightly more direct approach might involve somehow leveraging that text audio data set as like a pre-training procedure for your audio classification model, as opposed to like training a generation model first. I guess I'm curious, like between those two broad families of methods, like is there a particular intuition about why the generative approach is why that's more promising, or have you tried both and that's what worked better, or?
Yeah, I didn't try the second method yet, but I was curious to definitely I'm gonna do it in future work. But right now, like I'm focusing on the first one and try to see the limitation of that. So also like at Bosch, we are doing something on that direction, trying to see the limits. Mainly working with stable audio, which is like the latest like text to audio model that has been released, and the quality is really good compared with audio LDM and the one that we saw before. And right now, like I'm focusing on understand the limits of this model, because like maybe we can use this model not to generate all the data set or an entire data set, or we can mix the generative model with audio mixing techniques or signal processing techniques and try to like diversify the generation as much as we want. And then the other, like now I'm focusing on understanding the limits and where this text to audio model can better fit in the process, either like generating all the data set or some classes, or maybe you need to prompt that differently. Like right now we are working on the prompt techniques, and you can see a lot of difference in how the model is generating the quality of the model, like prompting, which is not, it's a prompt. So I think like there are a lot of things to investigate yet, but it's starting point. And then the next one, the next things that I wanted to discover, to research and to tackle is exactly what they say, like to try also to understand like how the generation can help us, how to fine tune the model, how to add like knowledge about the data set and the classes that you want to generate into the model. But then I think it depends, like at least like it depends a lot also on the downstream task that you want to tackle, because if you want like classify, it's a task. If you want like to have diversification for other tasks, it's different. So there's also a lot to discover like on that side. Is there only one way to prompt this model? Is that a different way? Do we really want to be able to prompt this model? Can they do it by themselves? How much? Yeah. But
Yeah, that makes sense.
Yeah.
Yeah, I mean, I think there's a really broad question here, like across the field of AI or machine learning, about like, there's a lot of people who are really excited about synthetic data as, you know, the path forward for scaling things up to the next order of magnitude beyond, you know, web scale data. And then there's a lot of people who think that's ludicrous, like, you know, You're not
Yeah.
going to just magically create new information by generating synthetic data. And I honestly don't know like where I stand on this debate. I kind of oscillate back and forth a little bit. But I do think it's super interesting, and also really interesting to see, you know, this kind of synthetic or generated data direction explored within the context of audio. So I think it's really cool work.
Thank you. Yeah, but I also agree, like I don't know, I've been fascinated and I wanted to discover like the limits and how to use them and how to like use them, not just to show that we can do it, but how to use it for some, I hope, like useful tasks. But there are limits. I don't know. I think like, yeah, as I said before, like for music, like I think when you play with them, like they're cool, but then like there are a lot of limitation yet. And I think there is a lot to discover to actually affirm that we can generate data as real data. But yeah, we'll see. I think we'll see a lot like in the next month.
Thank you.
I think that text is not like in some cases, text does not match music perfectly. Like when we say heavy sound, like there are like thousands of heavy sounds. But how do you think about like there are some limits to the text?
Yeah.
But how do you think about the limits of text?
Yeah, it's actually like something that I'm exactly currently working on right now, because for example, one of the limitations that I also saw like in the research I'm doing like with stable audio is exactly that if you're really precise about one sound, it's a dog barking, like it can change, can be like different pitch sound or different, the length, it can be different, but it's a dog barking. And then if you run the model without soundscapes, that can be more abstract, like I don't know, thunderstorm or birding in a park or something. It can be different sources that can, make like more sounds, and you have no control on that. And it's the same for music. Like I don't know if you use them, but sometimes it's really hard to just take the output of one instrument. And then you take like, okay, I want, I don't know, drum playing for 5 seconds or something. Sometimes you will have other sounds. And as you say, it's really hard to describe like what you want. And I think this is a big limitation right now. So also in that case, like I don't know where we'll go. Maybe we will go to multimodality image. Maybe you will give as for ChatGPT that you say like I want this, and then you give some example. Maybe we'll do that for music as well. I don't know, but I agree. Like it's really different. Also, the way I think we have to describe music, it really depends on the background, the culture. It really varies a lot, I think. That's also, I think that's also kind of like implicit biases. We give for granted that we prompt this model, that everybody will prompt the model as I do, or, but like we will prompt this model all differently. I think that's also like another interesting aspect of this model.
There's a question on the chat. It says, how can MIDI data be used to benefit the training of music generation models? Can it be used in parallel with the audio training data?
Okay. I'm not really expert like in MIDI. I never actually use them. I'm mainly working with audio, so I don't know if I'm the right person to answer the question. But I think that might be an interesting direction. I think there's been like some study that is going that direction, and for sure I'm pretty sure that people are using MIDI data to train like music generation models. I'm just not really involved like in symbolic generation music, so I don't think I'm the right person like to answer that. But I saw something about, so sorry about that.
Any other questions? Anyone else online?
I think
it was surprising you had difficulty getting it to get you finding a lady singing about summer. Were you able to change the prompts to find what you wanted?
I really wanted like that prompt, or like I needed to change a bit. Eventually I ended up having like a kind of like a female singer, but it really took me a while. like it wasn't the first prompt, the second prompt. It's really like, I don't know if you, sometimes even with ChatGPT, if you say like 10 times, eventually it will do it, but it was the same with music. Like, it was like, it really took a while before having like a female, kind of like female voice. Yeah.
I think that's interesting because a lot of pop music does have like female artists. So it just kind of talks about the kind of music that was being like the things that it was trained on.
Yeah, but also for images, the one that with stable audio,
Yeah.
it was the same, like pop musician, and they were
Yeah,
all white men. Like, yeah, I think I generated maybe 10, 50 songs before getting like a female one, and then it also depends. Maybe you're gonna prompt it and you get it immediately. I don't know. For me, that was the case. Yeah.
So can our group here take part in the survey that you were talking about earlier?
Of course, yeah, sure, and I think that
So
would
this
be.
will change your ratio of attention.
Yeah. And we really try, like we share the call, but the thing is that they need to be alive, even if you take it online, like you need it to be live. And also because of the time zone, sometimes it's really hard to motivate
We'll get
people
more
to take
details
this
about
one.
that.
Yeah, but sure.
We have to get up early. Right? Yeah.
Yeah.
Can I ask you a question if everybody else can ask? There's some consequences of the fact that when we ask for a generation, there's a variety of things that could all satisfy the prompt, the text prompt, and you were alluding to that in response to an earlier question. I want to come back to that because that has two different issues. One is, should we evaluate these text to audio generators based on one good quality would be that when I give it a prompt, it gives me a bunch of different things, not just the one best answer, but a bunch of things that are all kind of like that, some variety to choose from, because that's something people want in the system. And can we evaluate that? Like when we did the DCASE generative audio challenge in 2023, that was actually one thing we evaluated the systems on, was the diversity of samples that they made for like dog bark, like were they all the same dog bark or were there a bunch? And that was one of the dimensions. So is that something you're thinking about? And then connected to that is you look like you were really emphasizing human perception. And again, connected to that, when you evaluate, someone gives it a rating and they say that's a 5, there might be a lot of other things that would also give a 5 on a scale of 1 to 5 to, and so is there a way we could avoid this system going down a path just because someone gave it a 5, it just decides that's the best answer, but without losing the range of things that other things somebody might have liked. So sort of for the system, can we evaluate the systems on their diversity, and then can we do the perceptual evaluation in a way that takes that into account?
Okay.
Two really big questions. I'm sorry. Okay.
Yeah, what you mean is that if we can evaluate this, if we can take into consideration in the evaluation, consider the diversity.
Right, like if we do, so two different things. One is, I think, I'm just laying on this, that I think a text to audio system, if you give it a category, should give you a variety of things. I don't want a thing that just is like, this is your reggae pop song with a female, like this. I want a bunch of stuff that I can choose from, and I want a variety that's all good, right? And so are we working on that? Like, do we have any way to analyze that, like objectively, but then subjectively, when we're looking at human responses, if the prompt system is now going to say, oh, you liked that, okay, and then go to the next thing, have we lost some of that diversity because we just go down one path?
Yeah. This is something that we try to address, like in the study we did. That was like, and it's actually some I think a couple of participants like pointed out that it was like, I really like the output from a model, and I would like to use that output to not to fine tune the model, but like I want to edit something and I want to give it to the model back, kind of like taking an input and giving to the model back. And then with the personalization technique that we use, that is Green Book, that is coming from computer vision, we thought that there was some, it's called like catastrophic forgetting, that the model kind of like changed the distribution and learn everything with the new distribution we give, and this was like something that participants would have liked to see and do, but the model was a limitation of the model, or at least they were not able yet to do that. But it's something that people will, at least from the survey and the answer we saw, that's something that people are interested in, and I think we should consider that. Yeah.
Thank you again, Francesca. And I
Thank you
also
so
want
much
to thank
for
Laurie Heller for putting us in touch. It's very much.
Thank you so much. Thank you.